Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal Hakim bin Syed Bakri, nama matrik AF19002. We are from Group 9. We will present the design of foundation of three-story hotel at Simpang Renggam, daerah Keluang, Johor Darul Takzim. The project background. Our company Zen Creation Geoconsult Sustainable Hut has been assigned for an investigation of land for the purpose of building of three-story hotel at Kluang. This project is located at Simpang Renggam, which is in the area of Kluang. The rest of the location is Simpang Renggam, daerah Kluang, Johor Darul Takzim. A site investigation is carried out in order to get geotechnical engineering data underlying the site in order to provide data for the proposed structural foundation design, evaluation and subsequent construction. In this project, analysis of bore log, analysis of soil properties and column would be carried out. Other than that, design of foundation will be done in this project as well. Type of foundation and bearing capacity analysis will be determined in this project. The important thing is to design a safe and sound foundation for the structure which will be built on above. Our organisation chart. Our managing director is Muhammad Amirul Hakimi bin Abu Bakar Sobri. Our project manager is Muhammad Alif Haikal bin Rizwan. Our civil engineer is myself, Muhammad Akmal Hakim bin Bakri, and our geotechnical engineer is Muhammad Rashid bin Rosli. The depth from ground level of 0 until 0.15 meter, we identify the soil is as dark grey clay shade with little sand. The N value is 0 and gamma is 14.76 kilogram per meter cube. And then to 0.15 until 1.5 meter, the soil is firm, light to medium brown to red mottle grey clay shade with traces of sand. The N value is 5 and the gamma saturated is 14.76 kg per meter cube. And then for the 1.5 meter until 3, we identify the soil is firm, light to medium brown to red mottle grey clay shade with traces of sand. The N value is also 5 and the gamma saturated is 14.76 kg per meter cube. And then for the depth from 3 meter until 4.5 meter, the soil is firm, pale yellowish red mottle grey clay shape with traces of sand. The N value is 7 and the gamma saturated is still 14.76 kg per meter cube. And then to 4.5 until 6 meter, the soil is stiff, medium brownish yellow mottled grey clay shape with traces of sand. The N value is 10 and the gamma saturated is 18.91 kg per meter cube. And then for the depth of 6 meter until 7.5 meter, the soil is stiff, medium brownish yellow mottled grey clay shape with traces of sand. The N value is 13 and the gamma saturated is 18.91 kg per meter cube. And then for the depth of 7.5 until 9 meter, the soil is hard, light to medium brown straight pale grey sandy shape with little gravel. The N value is 50 and the gamma saturated is 18.59 kg per meter cube. And then for the depth of 9 until 10.5 meter, the soil is hard, pale brown spotted grey sandy shape with traces of gravel. The soil properties is the N value is 50 and gamma saturated is 18.59 kg per meter cube.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rashid bin Rosli. Next we proceed to the SPT part. In the standard penetration test, the boring was carried out with a casing NW size 76mm OD. The standard penetration test was carried out at 1.5 meter depth interval. A split spoon of 50mm diameter was driven into the soil with a 64 kg hammer falling freely from 760mm high. The recorded water table is 1.1 meter. The table shown below is the result for the SPT test. Next, we will go through for the calculation of friction angle. First of all, we must choose the depth with the different type of soil. Then using the all formula that have been given, we can calculate the friction angle. There are 4 friction angle that we choose. Then we will take the average of the friction angle which is 31 degree. For the column analysis part, first of all, we classify all the load to 4 types of column, which are C1, C2, C3 and C4. For the C1, the group of design pile is 1000 kN. For the C2 is 1500 kN. For the C3 is 2000 kN, and the last one for the C4 is 2500 kN. Okay, for the borehole analysis, we are able to get the value for the friction angle, which is 31 degree, the cohesion of soil 9 kN per meter square, and dry unit weight of soil, which is 14.67 kN per meter cube. The most important value that we get is friction angle of the soil, which is 31 degree. If we are able to get the friction angle of the soil, then we also manage to determine the value for the NC, NQ and N gamma. From the table below, as you can see, we get the friction angle, which is 31 degrees, so we managed to get the value for the NC, NQ and N gamma, which is 32.67, 20.63 and 25.99. That's all for my part. Thank you.
Assalamualaikum and hi, my name is Muhammad Ali Faikabir Rizwan, matrix number AF190020, and now I will resume the presentation. For the settlement analysis, elastic settlement is used, which apply the Berland and Burbage's method. In this table, this is the summary of Q prime alpha 1, 2 and 3 by using the Berland and Burbage method. Moving on to the soil improvements. The ground improvement of the soil sample is a technique to modify the engineering properties of the soil that can be carried out at a site. There are several soil improvement methods. The first one is the chemical stabilization. In the chemical stabilization method, there are two methods, which is cement grouting and fly ash stabilization. Next is removal and replacement. Soft dirt can be replaced. Soil displacement and replacement are the main methods for soil replacement. Removing and replacing soil improves soil bearing conditions. For the next method is dynamic compaction. Dynamic compaction is a cost-effective method of soil compaction in which a heavy weight is repeatedly lifted and dropped from a considerable height. The main objective of dynamic compaction are to improve strength and compressibility characteristics.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Hakimi bin Abu Bakar Sobri, F190089. I will continue with the soil improvement part, which is vibroflotation. Brown explains vibroflotation as a technique developed in Germany in the 1930s for in situ densifying thick layers of loose granular soils. The process involves the use of a vibrofloat called the vibrating unit. As you can see in the picture, we have 4 steps. For the step 1, the jet at the bottom of the vibrofloat is turned on and the vibrofloat is lowered into the ground. For the step 2, the water jet creates a quick condition in the soil which allows the vibrating unit to sink. The third step, granular material is poured into the top of the hole. The water from the lower jet is transferred to the jet at the top of the vibrating unit. This water carries the granular material down the hole. And the last step, the vibrating unit is gradually raised in about 0.3 meter lifts and is held vibrating for about 30 seconds at a time. This process compacts the soil to the desired unit. Okay, continue with the summary of design foundation. By using the methods that my friends explained before. Okay, so for the first column, the total load is 1000 kilonewton and the allowable load that we calculated was 1414.44, which is pass. Same goes to column 2. The total load is 1500 and the allowable load is 220 2266.8. Same goes to column 3, 2000, and the allowable load 3210.57. And column 4, 2500, and the allowable load is 3407.58. Okay, this is the area that we use for the all 4 columns, and the last row is shown the settlement of the soil for the all columns. Therefore, the shallow foundation is adequate to support the superstructure of the soil. Last but not least, foundation engineering knowledge such as analyzing bearing capacity, elastic settlement, and analyzing data ball logs can be beneficial to civil engineers in the future. The project's objective were also successfully met, so our project can be considered as a success.